Welcome to our video tutorial on data streaming with Apache Flink. In this video, we'll explore the fundamentals of Apache Flink, cover the installation process, and walk through a complete example of building a data streaming application. By the end of this tutorial, you'll have a good understanding of how to work with Flink and will feel confident to build your own streaming applications. Let's start by understanding what Apache Flink is. Apache Flink is an open-source stream processing framework for real-time data processing. It provides high throughput, low latency, and is fault-tolerant, making it perfect for data-intensive applications that require immediate processing. Flink processes data streams and allows for complex transformations on those data streams. Whether it's filtering, joining data, or aggregating, Flink allows you to build complex applications with ease. Now, let's talk about how to get started with Apache Flink. The first step is to download and install it. We will be working on a local machine for this tutorial. You'll need Java 8 or higher installed on your system along with Maven. You can download Apache Flink directly from the official website. Once downloaded, extract the archive to a suitable location on your machine. Let's verify our installation. Open your terminal and navigate to the Flink directory. Run the following command to start the Flink local cluster. Your terminal should display output indicating that the cluster has started successfully. You can also access the Flink dashboard in your browser at http://localhost 8081 to see the cluster status. Next, let's create our first Flink project. Make sure you have Maven installed. We'll create a new Maven project and add the Flink dependencies to our pom.xml file. Now, we need to add the Flink dependencies to pom.xml. Open the file and add the following dependencies for Flink streaming. Next, let's create a basic Flink job. In the src/main/java/com/example directory, create a new Java class called StreamJob. In this program, we import several Flink classes and set up the streaming execution environment. We create an input data stream using FromElements method, which generates a stream from a list of elements. We then apply a simple transformation using the map function, which concatenates processed to each element. Finally, we print the output to the console and execute the job by calling env.execute. Let's build and run this application. You can build the project using Maven with the command below. Once the build is successful, run the application using the Flink command line tool. You should see the output in your console displaying the modified strings. Congratulations! You've successfully created your first Flink streaming application. Now, let's dive deeper. In real-world applications, data often comes from sources like Kafka, file systems, or sockets. So, let's modify our application to consume data from a Kafka topic. To do this, we need to add dependencies for Flink Kafka. Modify the pom.xml file to include the Kafka connector. Now, we can integrate the Kafka consumer into our Flink job. Modify the StreamJob class to include the Kafka source. In this modified code, we set up the Kafka consumer with Bootstrap server details and configure the group ID. We create a Flink Kafka consumer and use env.addSource to consume messages from the specified Kafka topic. Make sure that you have a running Kafka instance and the topic input topic created with data being produced to it. You can produce messages using the Kafka console producer or any other method. Let's now build and run our application again to see the changes in action. As the application runs, you should see the processed input messages printed in your console. You can monitor your Kafka consumer group on the Kafka dashboard to ensure it is receiving messages. Now that you've learned how to consume data from Kafka, let's implement some more advanced features like windowing. Windowing allows us to process data in chunks or time intervals, making it easier to analyze streams of data. To demonstrate windowing, let's modify our code further. Add an import for the windowing classes. Next, we will apply a time window to our stream. Here's how to do this below. This code will aggregate data that arrives within a 5-second interval. The resulting window will contain the summed output of processed messages over that time period. Let's build and run our application again after these changes. You should see the output reflecting the sum of messages in 5-second intervals. Congratulations on making it this far. You now understand basic and some advanced concepts of Apache Flink. We covered installation, building a simple Flink job, integrating with Kafka, and applying windowing. Before we wrap up, I want to touch upon some additional features of Apache Flink. Flink supports exactly once processing semantics, which is critical for consistency in data processing. You can also leverage stateful processing, allowing you to maintain and update states while processing streams. To manage larger datasets, Flink also integrates well with distributed storage systems like HDFS and cloud-based services such as AWS S3, making it flexible for scaling your applications. I encourage you to explore the official Flink documentation for more advanced features such as complex event processing, CEP, and more detailed configurations. Thank you for joining this tutorial on Apache Flink. If you found this video helpful, please consider liking and subscribing for more programming tutorials.